Hello guys, am I audible to you? Please comment down in chat box. Hello guys, am I audible? Please write down in comment box. Good afternoon everyone. I will wait for 2 minutes, so call your friends if they are interested, then call them and ask them to join. Okay, let's start. Good afternoon everyone. I heartily welcome you for the today's session on the behalf of our club, Walchand Linux users. I hope you are safe during this pandemic and you have attended last 2 days of the webinar. So you might get idea about what is the Linux and some commands in the Linux. Now let's move toward the third day of LinuxDiary chapter 3, that is file system in Linux. Today I am going to cover the points introduction to file, then file system in Linux operating system, then inode structure and inode, and then directories, and in the last I will cover the file commands. Now here is a question though, what is data? So all of you know that file is used to store data, but what is data? In simple word, the data is a piece of information, so that may be any audio file, video file or text file or any other file. Now next one is introduction to file. Then now to store data we need a file. So file in a computer world is a self-contained piece of information available to operating system and any number of individual programs. So next point is what is file system. This is a point of today's discussion, that is file system. So what is file system? You may know the file reside anywhere on the disk or partition in operating system. So to keep the track of it, we require some methods and data structures. That methods and data structures are called as a file system. So technical definition of file system is a file system is a method and data structure that an operating system uses to keep track of files on a disk or a partition. That is the way the files are organized on the disk. So file system may differ from system to system. Let's see the features of file system and the comparison between file system in Windows and the Linux with comparison. The first one is a specifying path. In Windows, if we want to specify a path, then first we have to choose a drive, the name of the drive, then that is followed by colon and backslash. then the name of the folder or document in the drive, and again if that folder contains subfolder, we again need to use backslash and again the name of the subfolder, and at last the name of the file which we want to access. But in case of Linux, we can simply start with a forward slash. That is this is called as a mount point. So you will get to know it in later discussion. So here it start with forward slash, then directory name, so then the folder name, and at last name of the file. You can see the difference between these photos. First one is in Windows operating system, and next one is in a Linux operating system. So second point is a partition drive devices and directories. You might have seen in a disk management in Windows there are partition. So memory is divided into partition in Windows. So some or all of the partition can be used as drives, and drives are named as letters, example C drive, D drive, E drive, whatever may be it. Then but in a Linux there are directories represented as a tree-like structure. You will get to know more about directories in further session. As in yesterday's session, Yash have mentioned some directory structure. So I will explain in detail in further session. So the next one is a mounting and unmounting. As there are partition in Windows, it detects partitions and drives during booting process. But in Linux there are no partition. So after mounting devices, they get visible. Suppose if you mount a USB or hard disk, then that is visible in Linux. The next point is a case sensitivity. I think you have seen this example in day 1. So if you are having files with same name but different cases like shown below, in Windows they are treated same, but in Linux both are all the files are treated differently. Then next one is a file extension. In Linux, without the file extension you can save the file, but in Windows explicitly we have to specify that the file extension to the file. Then next one is hidden files. Linux also distinguish between hidden files and normal files like Windows. In Windows shows the hidden file in dark color, but in Linux the hidden files are indicated by a dot in the front of its name. Here you can see the example dot and the name of that hidden file, that is, let's say a dot hidden file. Now, as I discussed earlier, everything in Linux everything is treated as a file. Suppose if we mount any external devices like pen drives, hard disk, it is also used as a file. Then the feature of Linux file system is it supports Inode data structure. So I will explain it in detail in further session. Now move toward the next part of the today's discussion, that is the types of file systems in Linux. Now the first file system was Minix. It was basically designed for teaching purposes. Here the file name length was restricted to 14 characters only. In later version it is changed to 30 characters. Here the maximum file size was 64 megabytes. So it has some drawbacks, like the file name length was restricted to 14 characters and the maximum file size was 64 megabytes, which is not sufficient to store our data. So to overcome this problem, the next file system, that is extended file system ext, was introduced in 1992. So Also, although it has some significant problems, so it was quickly superseded by ext2, that is second extended file system. It was introduced just after 1 year of extended file system. So it stores the data in hierarchical manner. The maximum file size was 2 terabytes. It is too sufficient to store our data. The maximum volume size was 4 terabytes. The file name length was 255 characters. So you might get confusion between the max file size and max volume size. The max file size is the maximum amount of data that can file accommodate in it, and the maximum volume size is the number of files that can be accommodated in file system. So like Minix and first extended file system, that is ext, second extended file system also having some drawbacks. That is, it takes very long times to recover if system shut down abruptly, means if system shut down due to power failure. So if this happens, in order to clean up the file system, it calls the FCSK program, that is file system check program. So this program basically checks all the files when the system went down uncleanly. Instead of checking corrupted files, it checks all the files in the system. So it requires a very long time. So to overcome this, the third extended file system, that is ext3, was invented. So it has same file size, volume size and file name length as second extended file system. But here the new concept is introduced, that is journaling. So what is journal? So basically, before committing any changes to a file, third extended file system will record this transaction to the journal and mark it as a pending or incomplete. We need to write a data to file named schedule.odd. After that, ext3 file system marks that transaction as complete. By this, having a log of recent files and status whether they are completed or not in a journal. Suppose if we have the same problem like second extended file system, means if system went down abruptly, but in a third extended file system, it not check for all the files. Instead of checking all the files, it replaces only journal. But due to that, journal needs extra memory space and it does the system slow down. So these two are the drawbacks of third file system. So the next file system is fourth extended file system, that is ext4. For improving reliability, performance and capacity, ext4 was introduced. Here the maximum file size was 16 terabytes. The maximum volume size was 1 exa. So, it is an abstraction layer above the file system which provides an interface between the kernel and the file system. Some of the advantages of VFS are: it allows users to access files of various file systems. This means we can allow this allows very dissimilar file system types to be implemented with same structure. We can access remote files using VFS. So it provides the ability to uniquely represent a file throughout the network. We can perform many operations with VFS like open, read, write and close system calls. Now the next one is Inode. As I mentioned earlier, this word, the Inode, and also this was mentioned in yesterday's session. So what is Inode? Now Inode is a index number of data structure which will be associated with each and every files and directory. So here in the diagram, you can see the folder and file names and their respective Inode numbers. which will be stored in the inode table. Here given you the diagram of inode table. Inode doesn't contain actual file contents. It contains the pointer, means the address that will be point to the file content. Now let's see the fields in the inode. The first one is a mode. This is a node descriptor and user permission. The next one is the owner information. It shows users and group information. Then next one is the size, that it shows the size of inode in bytes. Then next one is the timestamp. This shows the creation and modification time of inode. And last one is the data blocks, that is a pointer to the data. Now let's see the structure of inode pointer to the file. So basically inode pointer contains 12 direct pointers. So here you can see these are direct blocks, can be pointed by 12 direct pointers of inode. This directly shows the actual content of file system. After that we are having indirect pointers. This also indirectly point to the actual, means it will point to the disk block. Here indirect pointers first point to the disk block, and the disk block work as index, and it point to the actual file content. Similarly we having double indirect, triple indirect. Now you may have question that both direct and indirect pointer used to point actual file content. But if we are having a direct pointers, then why there is a need of indirect pointers? So the use of pointers depend on the file of the size, on the size of the file. So to access the large file, we required indirect pointers along with direct pointer. Now let's clear this using an example. Here I am having a file f1.txt with a total size of 122 KB. Suppose each block in inode is having memory up to 8 KB, and as I mentioned earlier, there are 12 direct pointers. By using that direct pointers, I can access only 96 KB of that file. But if I want to access the further blocks, that is from 96 onwards to 120, so I require indirect pointers. So now move toward the directory. So now what is the Linux directory structure? Then Linux stores everything in different way than the Windows. When you install Windows on Windows operating system, you will directly get your C drive, D drive, and you can store data into it. But Linux keeps all these devices and data in the form of files in different location. Files are stored in folders, and folder has its multiple subdirectories, subfolders. Into you can keep your files. After installing Linux, you will not get any C drive or D drive, but you will get, that is slash, that is mount point. Under mount point, you will get a different directories which we are going to discuss here. So let me show the directory structure. Here you can see the slash represent the mount point. So the first one is a bin. You can see here bin. So slash bin. So slash bin is a binary files. Whatever the commands we use are stored in that directory. Let me show the contents of the bin. Here you can see the commands which like mkdir and ping or less, kill, which I already told in yesterday's session. All these commands is stored in the /bin folder. Now the next one is /etc. So here you can see that is etc. So whatever the configuration you do, that is you define a host name, or you define an IP address, or you configure your server, all this particular setting will be stored in /etc. So all the configuration files you will find. So whatever data may be created by user u1 is stored into /home/user1. So /home create a folder for user1, and all the data is stored in /home and the name of the user. Suppose if I go into /home, here you can see the only one user is present here, that is Sky. So it keeps only the name of the folder for users. The next one is the /opd. So all the optimized data we have will be stored in /opd. The next one is /tmp. So if you are doing some temporary task, like you are copying content of one file to another, that is it produces data into RAM, so that data is stored into /tmp. Once your system get rebooted, these temporary files get flushed out. So the /tmp is also called as volatile storage for your Linux operating system. And then next one we have is /usr. It contains all the user programs. Suppose you have installed some packages, or you have downloaded some packages. All these files will be stored in /usr. The next one is /var. So it contains all the variable files. Basically, whatever the variable files or variable data means which those things which are generally changed, that is which those data which generally varies and not constant, is stored in /var. So the last point of the today's discussion is file commands. Before getting started with file command, let's summarize points we have covered. The first one was what is data, then introduction to file, then what is file system, features of file system, types of file system in Linux, then inode and directories. So most of you have already attended yesterday's session. So write down some commands in the chat box which we have already discussed in yesterday's session. So I will wait for 2 minutes. Okay, let's move further. So let's revise some basic file command which I have already discussed in yesterday's session. So first one is a cat. So basically it prints the content of file to the standard output, that is on terminal. Then next one is a touch. This is used to create file. Then next one is a mkdir. Using this command we can create a new folders. Then next one is a rmdir. Like we can create a new folder using mkdir, we can delete them using rmdir. and the last one is a ls. This is used to enlist all the file in the specific folder. Now let's see some other commands related to the file system. So first one we have is a head. So it prints the first part of the file. Now I will show you demo. So head, by using head there are many options like -c for printing the number of characters, then -n for the number of lines, then -q. This prints all the contents to the standard output, but it does not print the name of the file. And the last one is -v, that is it prints the header of the file. Suppose here I will list the contents. Here I have the file called as linux.txt. So using head, if you want to print the first 10 characters of the linux.txt, before that I will show the file. Here you can see this is the linux.txt file, and suppose if you want to print the first 10 characters, then the command for this is head -c, the number of characters which we want to print, that is 10, and the name of the file, that is linux.txt. Here you can see the about and about space linu, that are the first 10 characters of that the linux.txt file. Then next one is a -n. Suppose if you want to print the number of the first 5 number of lines from the linux.txt, so we can simply write head -n, the number of lines which we want to print, that is 5, and the name of the file, that is linux.txt. Here you can see the first 5 lines of linux.txt file have been printed here. So next one is, if you want to print all the files without the head of that file, we can list head -q and the name of the file, that is linux.txt. Here you can see all the file content is printed here without the name of the file, that is linux.txt. Suppose if you want to print the name of the file and its content, then we can simply write head -v and the name of the file, that is linux.txt. Here you can see the name of the file, that is linux.txt, is printed here. So now move towards the next command, that is tail. This will work same as the head, but it prints the last part of the file. We can use same operation with the tail as I used with head. So let me show a demo. Suppose if you want to print last 15 characters of linux.file, then we can write a tail -c and the number of characters which we want to print, that is 15, and the name of the file, that is linux.txt. Here you can see space component that are the last 15 characters of the linux.txt. Suppose if you want to print the last 5 lines of linux.txt, so I will write tail -n, the number of lines which I want to print, that is 5, and the name of the file, linux.txt. So that are the last 5 lines of linux.txt file. And in similar way, the -q and -v is used with tail also. So now move towards the next command, that is move mv and copy. So mv will work just like cut paste, and copy will work like copy paste. So here you can see, suppose I have a file called as img3.jpg in the desktop folder, and suppose I want to copy in the folder. So I will create one folder called as WLUG. Here the folder is created, and suppose I want to move the img3.jpg file into WLUG folder. So I will write mv, the name of the file, that is img3.jpeg, and the name path to the folder, that is it is in a subfolder, so I will write down /WLUG. Now you can see the content of desktop. The file the img3.jpg has been moved to WLUG. To check whether it has moved in WLUG or not, we can go directly to WLUG and contents of the WLUG. Here you can see the image3.jpg has been moved to WLUG. And suppose if you want to move back again to the desktop, that is the parent folder of WLUG, we can write mv, the name of the file, that is img3.jpeg, and the name folder, that is parent. For parent we use ... and then /. Here you can see the folder is empty, so it haven't print anything. So just move to the parent, that is desktop, and show the content. Here you can see the img3 has been moved to again to desktop. Similarly, cp is used, but it creates copy of it. Suppose I want to copy the img3.jpg in WLUG. So instead of mv, I will replace it with cp. Now you can see here, this is the file is also here, that is img3.jpg, and we will go into WLUG folder to check whether it is copied or not. So here you can see the file is been copied in WLUG folder. Now the next command is a sort. This is used to sort a file. By default it sorts a file assuming the contents are in ASCII format. This can also use to sort the numbers. Suppose if the file contains both the numbers and letters, the first it sorts the numbers, then followed by letters. Now just see the demo. Here I have the file called as name.txt, so I will write down its content, cat name.txt. Here you can see the content of the name.txt file. Suppose I want to sort this, so I will write sort and the name of the file, that is name.txt. Here the content of that name.txt is sorted. Now again check the original content of name.txt, but it is not sorted. So you can observe that the change is not permanent. So if you want to save the change, you have to copy it in other folders or other files. So suppose I want to so the folder must be existed there, and so I want to save the change of name.txt. I will write hyphen, that is pipe, and the cat, and the greater than sign to override the content of already existed, that is I have file name called as sorted name.txt. So here you can see the content of sorted name.txt. Here the contents are has been copied to sorted name.txt. Suppose if you want to sort in the reverse order, so you can write sort -r and the name of the file, that is name.txt. Here you can see the file is sorted in a reverse manner. Similarly, like sort, the reverse sorting also does not, the changes are not permanent. So we should save changes explicitly using cat command. Now next one is a com. This is used to compare two sorted files line by line. So for that purposes we need sorted files. So I have one file. Suppose I already saved that changes to sorted name.txt. So you can see the first file sorted name, and second is a sorted name 2.txt. Sorry. And I want to compare both the files, so I will write com and the name of the file, that is sorted name.txt, and the another file, that is sorted name 2.txt. Here you can see the file contents have been compared and shown here. So next one is sed. So sed stands for stream editor. We can perform lots of operation on the file, like searching, finding and replacement, then the insertion, deletion by SCD command. But nowadays SCD used for find and replace only. So we can replace whole occurrences or nth occurrence or all the occurrences from the file. So let's see the demo. So just before getting started, just see the content of linux.txt, and here the word Linux is used more times. So suppose if you want to replace the word Linux with Unix, and throughout that file, so we can write command, that is scd, then in single quote the yes. Here yes is used for substitution, means replacement. Then slash, it is used as a delimiter. Then the first word, that is Linux, and the source, that is source which we want to replace with. And suppose I want to replace this with Unix, and I want to make that changes globally, that is I will write g and the name of the file, that is linux.txt. Here you can see the whole Linux, it has been replaced with Unix. So there is no word Linux in this file system. So if you check the content again, here the change, you can see the change is not permanent. So suppose if you want to replace only first occurrences of each line in the of word Linux in the file linux.txt, so instead of g I can write the number of occurrences. Suppose I want to replace first occurrences of each line, so I will write simply 1. So you can see only first occurrence of the file of the line has been replaced with Unix. Here the first one is a Unix, but in here you can see this is Linux. So only first occurrences of each line that contains Linux is been replaced by Unix. Suppose if you want to change from nth occurrence to all the occurrences, suppose I want to change content from second occurrences to globally, so I will write 2g. Here you can see the first occurrences is the same, that is Linux, but from second occurrences here is a Unix. Similarly you can see here is a Linux, but here you can see that this is a Unix. So next one is a grep. So basically it first searches for the given pattern, and then it displays all the lines and that contains the pattern. So we can perform many operations using grep. Some of them are listed below, like case insensitive search, then the displaying count that matches that pattern, and display the name of the file. So the number of lines that the number of lines of matched pattern. So let's see the demo. Suppose if you want to search word Linux insensitively, case insensitively, in linux.txt we can write grep -r, the word in double quote, that is Linux. So this is case insensitive. I can write in so Linux and the name of the file, that is linux.txt. Here you can see the word is highlighted by red color. So the next one is if you want to display the count of matched line of that particular word. So instead of -i we can write -c, but here we need to mention the word with correct cases, that is Linux. So here you can see there are 6 lines containing word Linux. Now if you want to list the number of lines that containing the word Linux, so instead of C you can write -n. So here you can see the line number 1, then 3, 5, 6, 8 and 10. These are 6 lines contains the word Linux. And for displaying the file names that matches that pattern, that is Linux, we can write hyphen instead of -l. And suppose if you want to search in whole desktop, then I will write star, that is for all. Here you can see in a purple color it shows that these are the files which contains Linux pattern. So the next one is WC. This is basically used to count the words in the file. Here you can see the file is named as speech.py. Suppose I want to find the number of words in that speech.py. With WC you can use -l and the name of the file to count the lines in that particular file. Then WC -w and the file name to count the number of words in that file. Then WC -c and the name of file to count the characters. So if I write WC and direct the name of the file, that is speech.py. Here you can see the 173302, but what are they? So instead of WC, I will write WC -l and the name of that file, that is speech.py. So -l is used to count the lines in that file. So here you can see the 17 is represented here is the number of lines in the file speech.py. Suppose if you want to count the number of words in that file, instead of L you can write W. So here 30 and here 30 shows the number of words in that file. And suppose if you want to count total characters, then instead of W you can write a -c. So here 302 the number of characters present in speech.py. So thank you. I hope you will get to know more about the file systems and the commands about the file system. If you have any questions, ask in chat box.